So now we move to exercise 3. So this one is what I mentioned before, like what I mentioned about this K. If in your pipeline you have a few of fittings, you need to consider all the fittings and add up all the fittings. So now I will show you the example. So exercise 3. The figure below show the plan view of a group of horizontal pipe made of galvanized steel connected in series. Plan view is a top view. So actually this one you look from the top. So determine the total heat loss between the ends A and B if the pipe are 100 mm diameter conveying water at a rate of 15 liter per second, given the absolute roughness of galvanized steel is 0.5 meter. Okay. So we need to know the total heat loss. So for the total heat loss, is a combination between the major losses and also minor losses. Okay, first thing first, we need to derive the Bernoulli equation. So this one is 0.1, this one is 0.2. So P1 plus U1 square over 2G plus Z1 is equal to P2 over 1G plus U2 square over 2G plus Z2. So in here we can cancel Z1, Z2 because mentioned here horizontal pipe, so there is no elevation. And please remember this is a top view. You look from top. So basically this pipeline is in a series. There is no inclination or elevation of the pipe. So we can also cancel out the velocity term, kinetic term, because there is no difference in the area of the pipe. So the velocity is constant. Oh, I'm sorry, apologies me. In this, basically for this Bernoulli, we have to consider the HF, which is this is the heat loss. So we have a major and also minor. So rearrange the equation. P1 minus P2 rho G is equal to HF. Delta P over rho G is equal to HF. Okay. So, okay, I want to explain a bit. Like what I mentioned before, this is the heat loss. So, consists of major losses and also minor losses. Okay, so for the major losses, okay, I write here. Remember in the part 2, we learn about HF is equal to delta P HF is equal to FL V squared over GD. Okay, so here we have G, we have L also we can get from here. D we have, V we can calculate. So F we will get from the, F is a friction factor we can get from the Moody's chart. So L here is a total length. So total length is from A to B. So we have to add up 3 plus 3 plus 4. 10. So V here we can have V, because we have Q and also we have the area, and then we can get the value of V. But before we go deeper, we need to calculate the Reynolds using equation rho U D over mu. So given in the question is rho U equal to Q over A, right? D over mu. So substitute all the information given. You can have 1.6748 times 10 to the power of 5. So with the given, in the question given absolute roughness, remember in the part 2 I mentioned about the to calculate to determine the friction factor for the turbulent flow. We need to have a relative roughness. So from this absolute roughness, we need to calculate relative roughness by divided the absolute roughness with diameter. You will have 0.0015. So with this value, you will get the friction factor from the Moody's chart here. With the 0.015, you will have 0.227. 0.0227. Sorry. Zero two two seven five. So for those who cannot remember how to use the Moody's chart, so like this. From the x-axis, define your Reynolds number, and then draw straight line up to the relative roughness. So 0.000015 is at this point, and then from this point you draw a straight line straight to the y-axis, and then you will obtain the friction factor. So after you get the friction factor, in this value you need to input inside this equation. Then you will have HF is equal to 0.423 meter. So we finish on the major. So this is major losses. Now we go to the minor losses. I think I need to erase this part so that I can write equation for the minor losses. So for minor losses, I use blue pen. So to calculate the minor losses, we use formula K V squared over 2G. Okay. Let's look at here. We have 1, 2, 90-degree bend and 1 globe valve. So for the HF minor, K bend V squared over 2G plus K bend V squared over 2G plus with K valve V squared over 2G. So these two, because it is the same, we can write like this: 2K bend V squared over 2G plus K valve V squared over 2G. So K bend is 0.9. Look at back here. K bend is 90% elbow, right? That one is 90 degree elbow, right? So the value is 0.9, and the globe valve is 10. Here 10. So we put inside 2 times 0.9 actually this V and G, it is same for this one, so basically we can move out the K. So 0.9 is for the bend, 90-degree bend, plus with K valve is 10, right, just now, time with V squared. So V squared here we have a Q. So please remember to change this one, the Q, to the SI unit, which is meter cube per second. So I write here Q is equal to 1.5 meter per square 1 liter is equal to 1000 meter cube. Sorry. One thousand meter cube, 1 liter. I'm so sorry. I got confused. So 1 meter cube is equal to 1000 liter. So cancel it out. Sorry, cancel here in here. So we have meter cube per second. So we become 0.0015. Remember, in your calculation, you need to show one by one. The unit conversion, the derivation, even though you have to expand or to modify the equation, like this Reynolds equation, you need to show one by one, because sometimes each one of your step got 1 marks. Okay, so we have 0.005. Sorry. Zero point 0.015 meter cube per second. So in here, V is equal to Q over A, right? So 0.015 over with pi d squared over 4. So all of this is in the square over 2 . So you will get the final answer is 2.194 m. So calculate the total plus with minor loss and major losses. So HF would be 2 plus with 0.423. So the answer is 7 meter.
Okay. Just now, we obtained the total between HF major and HF minor around 2.617, right? Okay. So, like what I mentioned in the class, the given question asking you to determine the total heat loss between ends of A and also B. So that means you need to calculate the delta P. The total heat loss, like what I mentioned inside class, is delta P. Okay, so the value of 2.617 just now, you need to time with rho, the one that we derived earlier, which is we cancel out this all of this and we obtain that P1 minus P2 is equal to rho G HF, right? So that HF is obtained from the total here, the total of HF major and also HF minor, which is 2.617, right? So that 2.617 you need to time with rho, which is 999.7, and then time with G, which is 9.81. So the final answer would be 25,672 PA. You need to calculate until delta P, because in the question asking you for the total heat loss between 2 point A and B. Okay, if the question asking you about the heat loss only, and then you can stop until the total of major losses plus minor losses. Okay, I think that's all. Thank you.